Today we will look at what a function is. We will look at the domain and range of a function. We will look at some specific functions where we talk about their domain and their range. We will also review how to evaluate a function. So a relation is any set of ordered pairs. The domain of a relation is the input values, or usually the set of all the x values. The range is the set of all the output values, or usually the y's. A function is a relation in which every member of the domain is paired with exactly one member of the range. So we can look at some different graphs of functions to determine whether or not each is a function. So the first graph looks to be quadratic. If we do what's called the vertical line test, we can tell that this is a function. If we look at the next graph appears to be a cubic, both polynomial. We can tell that we only go through the graph one point each time. As with the next is also a function. So all three of these are functions because they pass what's called the vertical line test. If we look at all of these, in fact, we will talk about how they all pass the vertical line test. So we can talk about the domain and range in what we call standard set notation or interval notation. I think that's something we've talked about already. So what we're going to do is we're going to look at some functions, talk about the name of that function, and then talk about the domain and the range. So this first one is definitely quadratic. I see it's an x squared quadratic. It is a quadratic function, also known as a polynomial. And if I would look at the graph, I'm going to go to my calculator, 3 minus 1.5x squared. If I would look at, I missed the 5. Missed the 5 there. There we go. That's my function, 3 minus 1.5x squared. If I would look at the graph of this, I see a parabola that does pass the vertical line test. And also I notice that the domain is all the reals because two things. If I look at the graph, I can see that it goes forever right, forever left. On the graph, every value and every point in between. And then also I can look at the equation and I know that I can square any number, and so the domain would be whatever I can plug in for x, and I will also get a y, and I know I can square any number. So I'm going to write the domain in standard set notation, all x values, such that x is an element of the set of real numbers. Then I can also talk about the range in set notation. Now, if I look at the graph, I see the graph does not go forever up and down like it goes forever right and left. It goes forever down, but it has to have a highest value. And I think that my highest value is, if we look, it would be 3. Let's see, we can test that by finding a maximum, finding the maximum point on that graph. And I see that it is 3 when y is 3. So I'm going to say all y values such that y is less than or equal to 3. Now if I wanted to say this in interval notation, I'm going to say negative infinity to infinity. We don't include infinity and we don't include negative infinity. Also, for interval notation for less than or equal to 3, we would say negative infinity all the way up to 3. We don't want to include negative infinity, but we do want to include 3. Okay, and then for number 2, y equals negative 2x plus 5, I can quickly look at the graph of that, negative 2x plus 5, and the graph of that is linear. And the one thing that I do know about lines is that they can go forever right, forever left. They also go forever up and down. And the domain and the range is all the reals. So for this one, I'm going to say, since this is a linear function, all x values such that x is an element of the set of real numbers, and the range would be the same thing. And in interval notation, for both, we would say negative infinity to infinity. Okay, the next one is a square root function. H of x is equal to the square root of x minus 5. This is called a square root function. Now, one thing, before I even look at the graph, one thing I do know about square root functions is that the number inside the square root has to be at least 0. It can't be negative. So when I look at square root of x minus 5, I'm going to go to y equals. I'm going to look at the square root of x minus 5. I expect it to be 5 and greater for my domain, and I see that. I see that x has to be at least 5 because the number inside the square root has to be at least 0. And so for the range, since the square root of something, we're talking about the principal root of the square root, which means has to always be at least 0. Square root of something, square root of 0 is 0. Square root of a positive number is always positive. So I'm going to say in set notation, I'm going to say all x values such that x is greater than or equal to 5. And for the range, greater than or equal to 0. And then in interval notation, I would say 5 to infinity, including 5, not including infinity ever, and then 0 to infinity for my range, and I do want to include 0. Okay, so number 5 is a quadratic, so that would be just like number 1. So we're going to go ahead and just look at number 4 for time's sake. I notice that number 4 is a fraction with variable in the denominator. And so we've talked a little bit about rational functions. This is a rational function. And right now we're only going to talk about domain for rational functions. We'll get more into range towards the end of the chapter. But I do want us to notice that the denominator of our fraction cannot be 0. So therefore, if I plug in 3 in for my x, then I will get a denominator that is 0. So I'm going to say not equal to 3. Sorry, not equal to 3. And then for interval, everything except 3, we would write it like this. We would say negative infinity to 3, but don't include 3, and then union 3 to infinity. I don't think that's anything too new. So what we've done so far is we've looked at some names, some popular functions. We've talked about domain and range. And those are, once again, rational and square root. Okay, so the last thing we want to talk about is how to evaluate a function using functional notation. So number 9 says to find h of negative 4 if h of x is the square root of x minus 5. So what h of negative 4 means is we're finding what is the value of the function. That's why we say we evaluate the function. The value of the function when x is negative 4. So h of negative 4 is the square root of negative 4 minus 5, which is the square root of 9. And we also all know that the square root of 9 is not a real number. So you could say something to the effect of does not exist. That's what deity is. Or you could say non-real or something like that. So let's find f of x plus 1 if f of x is x squared minus 4x. So f of x plus 1 means what is the value of the function when x is x plus 1. So we're going to, every time we see an x, we're going to put x plus 1. And then I'm going to simplify. So I'm going to multiply all this out and distribute my negative 4 and then add my like terms. So f of x plus 1 is x squared minus 2x minus 3. And then, lastly, g of 0. G of 0 is absolute value of 1.6 times 0 minus 2. So that would be the absolute value of negative 2, which is 2. So that's called evaluating the function. When we're in functional notation, that's what that's called. Look, I'll write it on the side. Functional notation. We use functional notation to evaluate the function. We don't say y equals, we say f of x or h of x or something like that. Okay, and then lastly, we can look at this last example, list the domain, standard set notation. Okay, so let's use our graph to help us. Square root of x squared minus 16. Looks like we've got this going on here. It looks like 4, x can be 4, x can be negative 4, because that's what would make the number inside the square root 0. But anything in between negative 4 and 4, the number inside the square root becomes negative. So that's why our graph looks like this. So we'll say greater than or equal to 4, or less than or equal to negative 4. All x values such that x is greater than or equal to 4 or is less than or equal to negative 4. List the range. Looks like, let's go back to our graph. Looks like we still have a square root, so we know that the number in the square root of something is always at least 0. So we'll say all y values, let me move that down. All y values such that y is greater than or equal to 0. F of d plus 3. So we're going to do square root of, remember every time we see an x, we're going to put d plus 3. So this is, oops, I meant to write minus 16. So you could simplify this if you wanted. It'd be the square root of d squared plus 6d plus 9 minus 16, which would be the square root of d squared plus 6d minus 7. And we're looking for intercepts, also x-intercepts. X-intercepts are x's when y is 0, so we'll plug in this. So how would I solve this equation? I'm going to square both sides. 0 squared is just 0, add 16, take the square root, and we get plus or minus 4. 4 comma 0. And negative 4 comma 0. Okay, so for homework, you're going to do the homework page that says chapter 2 domain and range set and interval notations, and then it has a little bit of evaluating at the bottom.